Okay, so 6.1's transformations. If you're good with geometry and like visual stuff, you shouldn't find this too bad. Hopefully you do. Let's read through this. Single transformation, so only one change at a time. First of all, a transformation is just moving a shape from one location to another. So I say a translation, that's just a slide, up or down. Left, right is horizontal. Translations up and down is vertical. There's an example there. To the right. To the right, 5 squares, right? Because this one went from here to there, 5 over. A reflection is a mirror image, right? Often you'll say there's a reflection line. We often use the x-axis or y-axis. But it could be anything. It could be you could draw it any other line, like reflection. A rotation is where you twirl something circular-wise, right? 90 degrees, 180 degrees, etc. Okay? Then know this term, a dilation. That's making something twice as large or possibly smaller. A dilation in math can be half the size, a third the size. I'm sorry? It's the ratio, yeah. It is in proportion. So, were you working on example 1 already? Yeah. So, you probably had this. I'm going to just take a look here. So, A. Basically, if you do one point, you can draw the rest of the figure, right? So if I'm supposed to move 6 to the right and 2 units down, so 1, 2, 3, 4, 5, 6, 1, 2. 2 units down, that's where my new A would be, right? So I'm going to call that A prime, 1 tick mark on it. The other ones would all do the same thing. So I'm going to just draw this, knowing that E is just down 2 over 2. B is the mirror image of that one. And C is 3 down from that. D is 3 down from that. So. Okay, and of course you can connect your dots. And there you go, there's your new shape, right? No problems there? What are the vertices? Okay, can you read, the vertices are the ordered pairs, right? Can you rattle those off? What's A's vertices? X, comma, Y. Or vertices, coordinates. Yeah. 4 comma 0. Good, you remember this then. So then E would be 6. Then negative 2. 6, then negative, what's that, 5? You watch, because I'm doing this. I make mistakes. What's this, 2? Negative 5. And you have to use those round brackets around them too. And then that's 2 comma negative 2 for B. Okay. Now, example 3 shouldn't be too bad. Flip it over the y-axis mirror image, and then the x-axis. So, I guess we'll do A first. I'm going to use this color for A. Over the y-axis. So from left to right. A, I'm supposed to use A tick mark, A prime. Label that. B would be straight over 3 over from there, okay. And then C would be 1, 2, and just so people who are watching can see. 1, 2, 3, 4, 5, 6, 7. So it's 7 over from the y-axis. 1, 2, 3, 4, 5, 6, 7. So that's where my C would be. Then I could just join the dots. Now my shape. Now, I have a hard time drawing straight lines with this smartboard sometimes, unless I use that line. There, that's a little better. How about the B? The x-axis, no problem? Give that one a shot. We'll see if we have the same answer in a minute. Okay. Is it looking decent? Am I right? I think I am. Okay, and you're good? One last example, or no, two more examples. Each of these letters, a line of symmetry, a reflection line. So this isn't asking you to reflect it, but if you could draw a line of symmetry, where would it be? I'm going to use my line maker here, but I'm going to choose a color for it. I'll go with blue just so it stands out a little more. Okay, the letter A. How would you chop it? Do a hand motion or whatever. How could you chop it so that it's straight down the middle, right? That'd be its line of symmetry. How about the letter C? This way, right? How about the letter R? Can't do it. It doesn't get chopped. How about the letter D? Yeah, left, right. Horizontally. How about H? How about, there's another way. Okay, the U is up or down, but look at this. H you could also have done this way. Okay. So you can have more than one line of symmetry sometimes. The R, none. That's for the R, no symmetry. Now, the rotations are different than the reflections. This shape, though, is confusing because, oh, I'll move now. This is kind of confusing at first because it doesn't, I'm just checking here. Yeah, it is. It's symmetrical, this object. So when you spin it, it's not quite, it doesn't look any different than reflecting it. But that's not always the case here. So, if you're going to reflect, does it say clockwise or counterclockwise? Oh, clockwise, okay. So if you reflect clockwise, so going this way, right? Oh, no, went too far. 90 degrees is just into this quadrant, right? So just think of this. A will stay where it is. We'll do this here. Here's our 90 degree. Now think of this. I've got D. Now if I reflect that 90 degree, or reflect, I said the wrong word. If I rotate that 90 degrees, oh wait. Does this make sense that if I rotate, it's like moving in a circle, 1, 2, 3, this is where the new D ends up. Because it's like I take this whole shape, and I can't show this easy on here. I'll try it, but I don't know that it'll work. Now, what I'm trying to do is actually rotate it, but it rotates around the center. How could I do? Pardon? Okay, sorry, I can't hear you. Okay, I can't rotate on this board very easily, like to show the rotation thing. But what happens is then, like C, you got to think about 90 degrees from here. Is going to go over here, right? So this is where my D ended up. This is where my C ended up. And then finally, my B to go 90 degrees will go, okay, I spun a little too much. Here you go. So you get the same shape, just spun around a little bit. Make sense? Okay. My drawing doesn't have straight lines. It's not very good. But then 180 degrees, that's spinning from, say, here over to there, right? So it's exactly halfway around the circle. So when you do that, you should have your C value going around to about there. That would be where the new C would be. And the D, spin around. And then finally your B. It's always best to do these corners, right? Spin around. Lastly, we're talking about 270 degrees. It's going to be over here. I should have marked that down here, 180 degrees spin. But the C value, it spins, this should be about right. That's where the new C would be. Oh, wrong pen. And then the B, or D, I'll do D. Spin. There. And lastly, the D. Oh, I'll erase that and disconnect it. Spin. And we can connect those. Yeah? Okay. So the very last thing is you had already mentioned this with dilations. It's just going by a scale factor, times 2 or times 0.5, half of a something, third of a something. A dilation can be bigger or smaller. So let's see here. Each square represents a centimeter, so it's a 4 by 2 centimeter rectangle. Dilate it by a factor of 2. What are the new lengths? So, yeah, exactly. Just double everything. Yep. Okay. Well, Yeah, we didn't even need to, I guess it doesn't say you have to draw. Let's just do the side lengths and we can draw after, because there's 3 drawings possibly. Or what? Here's what I'll do afterwards. Okay. So we know that the side lengths are going to be dilate the triangle, or rectangle by a factor of 2. So like you're saying, 4 cm by 2 is 8 centimeters, and then the 2 centimeters by 2 is 4 centimeters. So those are your 2 dimensions. It's an 8 by 4 centimeter. So if I did that here, you would just take that and make it. Well, this doesn't do it. Okay. Anyways, my shape here isn't very good. I thought I could maybe stretch it like that, but it doesn't work as well as I thought. Anyways, though, you just make it 4 by 8. There you go. Now, doing it by a scale factor of a half, I think you can do the math in your head. Half of 4 centimeters is now 2 centimeters. Half of 2 centimeters is 1 centimeter. That's the new one, right? So it would be, I'm going to draw a green in here. Can you see that even? It's hard to, yeah. So that's the B one. The dilation of a rectangle resulted in 14 by 7. What scale factor was used? You could probably, what scale factor was used? Well, let's just see here. If you want, you can set it up as the old, yeah, basically. You'd say, well, the 14, I'll go with blue on that. Yep, dilate by half, 0.5. So make it half the size for each side. Actually, you do multiply. When you multiply by a small fraction, it makes it smaller, right? Like think 12 times 1/2 is 6. That's, I know people say, well, it's multiplying, how can it be smaller? But if you multiply by a portion, by a fraction, it will be smaller. Just trust yourself. It is. Anyways, so like you were saying, if you say 14 divided by the 4 centimeter side, 7 divided by the 2 centimeter side, you should get the same number twice. 14 divided by 4, 7 divided by 2, it's 3.5. You could use your calculator to do that. So the scale factor used, 3.5 is the scale factor. So you can have decimals, you can have whole numbers for these scale factors. Okay? Now, get familiar with the lingo as much as anything. The words dilate and so on. Yeah, because if I say translate, if I say dilate, if I say rotate, you should know what it means that you're doing.